Okay guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 25 sa ating advanced calculus. Ito na yung Cara, Theodory, Lemma. So ano ba sinasabi? So proposition number 1 para dito sa ating differentiability. So proposition 1, that is the Cara, Theodory, Lemma. So f is differentiable at c. So ito yung f prime of c. If and only if there is f sub 1 mapping from d to real number such that f of x minus f of c is equal to x minus c times f sub 1 of x for all x element of d, and f sub 1 is continuous at c. Moreover, if f prime of c exists, so that is exists, then f prime of c is equal to f sub 1 of c. Kasi nga si f sub 1 of x is continuous at c, so ito yun. So ibig sabihin, ano nang gagawin natin? I-evaluate natin yung f of x minus f of c. Ang goal natin, dapat makapagpalabas ka ng x minus c. Pag napalabas mo yung x minus c, yung natirang function doon, yun na yung f sub 1 of x. Tapos evaluate mo siya at c. Tapos yun na yung kanyang derivative. Ganun kasimple. So by the way, yung tawag dito is the increment function. So f sub 1 is the increment. This is the increment function. So ito yung way, ito yung second way para mas show natin na differentiable yung isang function. So I think mas pipiliin nyo to kasi mas maikli siya kumpara dun sa pagkuha ng limit dun sa ating definition of derivative. So again, let us use Cara, Theodory, Lemma to show the following is differentiable at c. So suppose we have f of x equal to x squared plus 3x plus 5. So show that this is differentiable at x is equal to c. So suppose at x is equal to c. So using Cara, Theodory, Lemma, so anong gagawin natin? So ang sabi, f of x minus f of c lang. So ang goal natin, evaluate mo si f of x minus f of c. Kasi yun yung goal eh. Ang unang step, check mo si f of x minus f of c. So after nyan, si f of x, so si f of x minus f of c, that is equal sa x squared plus 3x plus 5. Tama? Then minus, this is minus c squared minus 3c plus minus 5 kasi naka-minus. So minultiply ko na rin yung negative. Okay, then pagsamahin natin yung mga x squared saka x squared c squared. So kasi ang goal ko lang kung makapagpalabas ng x minus c. So dito, ang gagawin ko, this is equal sa x squared minus c squared, then plus 3x minus 3c. Tama? Then 5 minus 5 is 0. Maka-cancel kasi yun. Tama. So, kasi 5 minus 5 is 0. Next is factor out ko to. This is equal lang sa x minus c times x plus c, then plus 3 times x minus c. Yan, kung napansin mo, meron x minus c both. So, i-factor out natin yan. Ang result natin is, pa-factor out ko sa x minus c. Okay, may matitirang x plus c, tapos plus 3. Kasi ando dun yan. So, x plus c plus 3. Okay, so kung napansin mo, napunta na tayo sa form na to. X minus c, na-factor out ko na. Okay? Then, sabi, yung matitira daw, yun yung increment function. So, therefore, itong part na to, yung ating f sub 1 of x. Okay, so sabi, evaluate f sub 1 of c. Since yung f sub 1 of x natin is x plus c, f sub 1 of c is just equal to yung x papalitan ng c plus 3, which is equal sa f sub 1 of c is equal to 2c plus 3. Note, by definition, si f sub 1 of c is equal to f prime of c. Okay, so since f prime of c is equal to f sub 1 of c, therefore f prime of c is just equal sa 2c plus 3. Okay, so f is differentiable at x is equal to c. So tama naman, bakit sir? Ang derivative nito is 2x plus 3. So palitan mo ng c, that is 2c plus 3. So nakuha ko yung derivative. Tama, no? 2x plus 3 ang derivative, that is 2c plus 3. Okay, so again, ang goal mo is makapagpalabas ng x minus c. Yung matitira, automatic siya yung increment function natin. So hoping na bantayan mo yan. Okay, next. Number 2, f of x is equal to 1 over x. So paano naman pag ganito? So ganun ulit, at x is equal to, ibahin ko konti yung number. Kunyari at x is equal to 3. So ito iba idea nito. So dapat f of x minus f of 3. Tapos kailangan makapagpalabas ako ng x minus 3. Kasi yun yung silatin eh. Okay, so tama naman, differentiable siya dun. Okay, so check na lang natin. So try natin si f of x. So consider si f of x minus f of 3. So again, no need to solve. So this is equal sa 1 over x minus 1 over 3. Okay, then cross multiply. This is equal sa 3 minus x all over 3x. Okay, then factor out natin negative sa taas. That is equal sa negative of x minus 3 over 3x. So ang goal natin makapagpalabas tayo ng x minus c or x minus 3. So therefore this is x minus 3 multiplied by negative 1 over 3x. Okay, so therefore ano yung increment function natin? So therefore ito yung f sub 1 of x. Okay, so note na yung f sub 1 of x. So goal natin is solve si f sub 1 of 3 kasi yun yung pinapasolve. So that is equal sa negative 1 over 3 times 3 or equals sa negative 1 over 9. So note that f prime of 3 is equal to negative 1 over 9. Okay, so tama naman. Bakit sir? Kasi ang derivative nito, so note no, ang derivative ng f prime of x natin is negative 1 over x squared. So at x is equal to 3, that is simply negative 1 over 9. So tama yung nakuha natin na derivative. Okay, so yan yung other way para ma-solve siya. So nakapagpalabas pa rin. So importante mapalabas mo yung x minus 3. Okay, so next. What if naman is if square root? So pag square root naman, syempre ganun pa rin. So ako na lang i-ano ko lang siya at x equal to c lang. Medyo mahirap eh. So at x equal to c, so solve natin siya. So solve natin si g of x. Solve natin si g of x minus g of c. That is equal sa square root of x minus square root of c. So ang tawag sa gagawin ko is the rationalization. So meaning, i-rationalize ko siya, i-multiply ko siya by square root of x plus square root of c over square root of x plus square root of c. Para mapalabas ko lang yung x minus c. So pag binultiply natin yan, that is simply sa taas magiging x minus c na lang over square root of x plus square root of c. So rewrite lang natin konti. This is x minus c multiply by 1 over square root of x plus square root of c. So obviously ito na yung f sub 1 of x natin. Okay? So evaluate natin si f sub 1 of c, that is simply 1 over square root of c plus square root of c or simply 1 over 2 square root of c. So ito na yung f prime of c natin. Okay, so tama naman kasi ang derivative ng square root of x is 1 over 2 square root of x or derivative of x over 2 square root of x, which is derivative of x is 1. So tama naman yun nakuha natin. Okay, so ganun lang siya kasimple. Okay, so next is we have h of x is equal to ln of x. So ito yung example na kung saan hindi applicable si Cara Theodory lemma, or I think hindi ko pa na-discover yung solution o yung way para ma-solve natin siya dito. Okay, so ang gagawin na lang ni sir is just so again ito yung explain ko sa inyo. Hindi sa lahat ng oras applicable si Cara Theodory lemma. Bakit? Kunyari nag-Cara Theodory lemma tayo dito, ano mangyari? Kukunin mo si h of x minus h of c. So kunyari at x is equal to c. So for greater than 0, mga ganun. So mangyari, this is just ln of x minus ln of c. So napakahirap dyan. So sir, factor ko yung ln, sasapukin ka talaga sa pag ginawa mo yun. Hindi pwede yun, no? Factor mo yung ln, lalabas x minus a, so magiging ln of something. So alien ka, sasapakin kita. So isa to sa mga way bakit hindi sa lahat ng oras kaya natin gamitin sa si Cara Theodory lemma. So usually pag transcendental function, okay, kunyari sine, hindi rin applicable si Cara Theodory lemma dun. So sa mga transcendental function, hindi natin kaya i-apply si Cara Theodory lemma. Pero pag mga algebraic, go, kaya mo yan. Okay, so therefore, kung hindi applicable si Cara-Theodory lemma dito, ano yung applicable lahat nandito? Ang applicable dito is definition of derivative. Kasi definition of derivative, halos lahat ng limit nakuha na natin eh. Okay, so meaning, pwede natin itong i-apply dito. So, paano yung gagawin natin dyan? So, by definition of derivative, we have, so kunyari na lang, f prime of x na lang tayo. Kunyari, kunin ko na lang at x. So, f prime of x is equal to limit as h approaches 0 ng f of x plus h minus f of x. So, sa x lang ako, hindi sa c, over h. So, apply natin, this is equal sa limit as h approaches 0 ng ln of x plus h minus ln of x all over h. Okay, next is factor out ko lang yung 1 over h dyan. Okay, so this is equal sa limit as h approaches 0 ng 1 over h, okay, multiplied by ln of x plus h minus ln of x. So, apply natin dito yung quotient rule ng logarithm. So, by quotient rule ng logarithm, this is just equal sa limit as h approaches 0 ng 1 over h multiplied by ln of x plus h over x. So, kung naaalala nyo yung rule ng ano natin, diyan napapagod na sa sir, sorry. So, this is x plus h. Okay, so kanina pa ako nag-video. Okay, next is gagawin ko, since naka ln na siya, ito pwede ko iangat doon kasi may property na kunyari a ln of u, aangat siya. Tama? So, pwede ko iangat to. So, this is equal sa limit as h approaches 0 ng ln of x plus h over h raised sa 1 over h. Okay? Then, solve ko lang konti yung nasa loob. So, ano mangyari? That is h over x, I think. Ay, sorry. X to, no? So, this is x. So, simplify ko lang konti to. This is equal sa limit as h approaches infinity ng ln of x over x is 1 plus h over x as raised to 1 over h. Okay, so next is, ano ba ang pwede natin gawin dyan? Mag-change of variable tayo dito. So, paano bang change of variable? So, ayun o, mag-change of variable ako. Maglilet ako ng, so, let u is equal to hx. So, ano yung h? ux is equal to h. So, dalawa yung mangyayari dyan. Pag change of variable ko, that is limit. So, change of limit din. So, since u pa rin siya, h approaches infinity, therefore, h approaches infinity pa rin to. So, this is u approaches, sorry, 0 to, no? 0. So, h 0, so u approaches 0 pa rin. Tama, kasi when h is 0, u is approaches 0 pa rin. Next, ln of, this is ln of 1 plus, yung h over x is u. Tama, yung 1 over h is 1 over ux. Tapos, konting arrangement lang konti dyan, ayusin ko lang. Ang gagawin ko, this is equal sa limit as u approaches 0 ng limit. So, dadalawihin ko yan ha. Ang mangyayari ganito, magiging 1 plus u, okay, raised sa 1 over u, hiniwalay ko, tapos may 1 over x. Okay, ito ay ln, sorry. Paglilito-lito na ako sa number. Okay, next, yung ln na yan, bababa ko yan dyan. Pwede mangyari yun. Okay, so bababa yung ln, tapos since yun na siya, yung ln na yun, pagbaba dun, ito mangyari, this is limit as u approaches 0 ng 1 over x, tapos ln ng 1 plus u raised sa 1 over u. Okay, next. Since maapektuhan na lang is just yung ln natin, so ang gagawin ni sir is pwede ko yung pagpalitin, yung 1 over x ilalabas ko, tapos since continuous lagi yung limit, yung ln is continuous sa kanyang domain for our positive number, for positive real number, ang mangyari, pwede kong pagpalitin. Pwede yung ln lalabas, tapos yung limit papasok. So, ito yung gagawin ko ha. Ilalabas ko yung 1 over x, tapos ln. Okay? So, gagawin ko siyang ln of something, tapos ito yung limit as u approaches 0 ng 1 plus u raised sa 1 over u. So, again, pwede yan gawin pag ikaw ay continuous sa inyong domain. So, continuous naman siya sa domain na, ang domain niya kasi is ito. So, ang domain niya is 0, positive infinity. So, since continuous naman yung ln of x dyan, so, pwede kong gawin yan. So, kung naalala niyo sa mga property ng ating, so, ayan, pwede kong gawin yan. So, ngayon, next is, note na ito is yung parang famous equation. Yung tawag kasi dito is, kung mababasa nyo to, yung limit as u approaches 0 ng 1 plus u raised sa 1 over u is just equal sa e. Okay, isa yan yung irrational number. So, therefore, saan equivalent to? So, therefore, this is equal sa 1 over x tapos ln of e, in which this is just 1 over x times 1, which is that is only 1 over x. So, tama naman na derivative ng ln of x is 1 over x. Okay, so therefore, this is done. So, siya ay differentiable doon. Okay, so tama naman ang derivative ng ln of x natin is h of x. So, ito yung h prime of x. So, wala palang done symbol. So, disregard yung done symbol, wala yan. Okay, so hoping na naintindihan mo. So, again, si Cara Theodory lemma, hindi siya applicable pag transcendental. Para sa akin, hindi ko pa kasi wala pa kasi talaga akong nakitang example na kung saan applicable si Cara Theodory lemma dun sa transcendental function. So, usually, ang limit lang kay Cara Theodory lemma is algebraic lang. Pero, ayun nga, ang use naman ni Cara Theodory lemma is pwede natin gamitin yung Cara Theodory lemma para i-prove naman yung mga properties ng derivative. Yung mga chain rule, yung quotient rule, yung product rule, okay, yung identity rule. So, lahat yun kaya natin i-prove using si Cara Theodory lemma. As long as hindi transcendental function. Okay, again, thank you for watching. So, hoping na naintindihan mo yung idea na sinasabi ni Sir dyan.